I got this feeling inside my brains. It goes electric wavy when I make them A's. All through 4th grade, all through my school, we're flying up no ceiling when we're in our zone. I've got that sunshine in my pocket, looking forward to a good day. I feel I can do everything when I try. I can't stop myself from learning, moving up academically. We'll unlock the way we rock it, so don't stop.
Hello everyone, I hope everybody's having an amazing day today, because today we are gonna get started in math. Why do I need to know about the measure of an unknown angle formed by two non-overlapping adjacent angles given one or both angle measures? Wow, that is a lot. Trust me, it isn't, okay? We're gonna go over a few things today, and then tomorrow in my part 2 video, I'm just gonna go over a few things, and then bada bing bada boom, you already know what to do. You've already learned it, okay? So don't worry, you got this. I believe in you, so you believe in yourself too. Okay? So let's go ahead and look at the next slide. This is TEKS 4.7e, okay? So, very important picture. If you see this little guy, pause the video and write down what is on the screen, okay? Make sure you're writing all this down in your notebook so that way you can get your notes together. Let's go over our objectives for this T. Students will know how to use a strip diagram to help them find the measure of different angles. Students will understand how to identify supplementary and complementary angles. Students will be able to share in a group discussion how to determine the measure of an unknown angle formed by two or non-overlapping adjacent angles given one or both angle measures. Okay? And then here it is in Spanish. So we're going to be learning about adjacent angles and how to find any of the measures if it's not given to us. Okay, that's what we're going to be learning today. Here are the essential questions for this lesson. What operations would you use to determine unknown angles? How can you identify complementary angles? How can you identify supplementary angles? Okay. Remember, by the end of both videos, you should be able to answer these questions about complementary and supplementary angles and what type of operations you use to determine unknown angles. Here is the vocabulary that we'll be using in our lesson for today and tomorrow. Adjacent angles, supplementary angles, and complementary angles. What is adjacent angles? These are angles that share a vertex and a ray. Okay, so for an example, here is an array. An angle. And then this one is also the next angle. And they share a vertex, which is vertex B, point B. Okay, so that's what it is. Two angles that share a vertex. ABC and CBD. ABC measures 26, CBD measures 33. What is complementary angles? These are two angles that measure up to a sum of 180. Okay? So for an example, here is the line which measures 180. Okay? So here is where there's one angle right here. Oh, that's green. Right here. So this whole thing. and this one right here that measures 60. 60 plus 120 equals 180. So both this angle right here and this angle right here equals up to 180. And that's what supplementary means. When two angles, they equal up to 180. What is complementary angles? This is when there's two angles and their sum is 90 degrees. Okay, so here's one angle which is 60 right there, and then here's another angle and it measures 30. So 60 plus 30 equals 90. Okay, and 90-degree angles is what type of angle? Good, a right angle. Let's go ahead and watch our video for today, and let's see what we can learn from them.
Quality writing makes your schoolwork better and helps you stand out in the process.
Hi, welcome to Math Antics. We're continuing our series on geometry, and today we're going to learn about angles. In our last video, we learned about points and lines, and that's good because we're going to need lines to make angles. So let's start with a couple of lines that are in the same plane. We're only going to be dealing with two-dimensional geometry in this video. These lines are conveniently called line AB and line CD. Now, the important thing to notice about these two lines is that they're pointing in exactly the same direction. So even if we extend them forever, they would never cross or even get closer together. When two lines are arranged like this, we call them parallel. Now, you've probably heard the term parallel before, like parallel parking or a parallel universe or parallel bars. Okay, so parallel lines are lines that will never cross, even if they go on forever. But what if I take one of our lines and give it a little nudge? Now the lines aren't parallel anymore. In fact, they cross at this point right here. Let's name it point P. When lines cross at a point like this, we say that they intersect, and we call the point an intersection. And when lines intersect, they form angles. You can think of the angles as the spaces or shapes that are formed between the intersecting lines. These intersecting lines form four angles: 1, 2, 3, 4. But instead of calling them angle 1, 2, 3, and 4, in geometry, we name them by the points used to make them. For example, this angle here can be called angle DPB because if you trace along those points, like connect the dots, they outline that angle. And this angle here, we can call that angle APD because connecting those dots forms that angle. Now, when naming angles, there's a nice shorthand that we can use. Instead of writing the word angle over and over again, we can just use the angle symbol instead, which looks like this. But there's an even simpler way to name angles. To learn that way, let's erase all the points and letters on our lines except for the intersection point and this one point here. Now let's imagine that the line segment between these 2 points can rotate around the point of intersection just like a clock hand rotates around the center of a clock. Let's also imagine that as we rotate the line segment, the point out at the end leaves a trail, like if a pencil was attached to it. The trail, or path, that's left when we rotate the line segment all the way around forms a circle. But if we only go part way around, then it forms part of a circle that we call an arc. This arc can represent the angle that's formed when we rotate the segment from one position to another, like from this line to that line. And now, if we shrink down that arc so that it's close to the intersection point, and then put a letter by it, like the letter A, we have another way of showing an angle, angle A. And we can do this with any angle. So the angle up here, we can also draw an arc and call it angle B. So whenever you see a letter next to a little arc like this, it means that it's the name of the angle formed by that arc. All right then, so now we have a diagram that shows angle A and angle B. And you might notice that those angles aren't the same size. B seems to be bigger than A. But what if we rotate one of our lines until the angles do look like they're the same size? Now our angles look kind of like a plus sign. Lines arranged like this are called perpendicular. Perpendicular lines are lines that form square corners when they intersect. And these square corner angles have a special name in geometry because they're really important. We call them right angles. There's even a special symbol that we use to show when an angle is a right angle. Because they form square corners, we use a little square instead of the arc that we use for the other angles. So whenever you see this symbol, you know that the angle you're looking at is a right angle, and that the lines that form it are perpendicular. Okay, now that you know what a right angle is, let's look at a simple one that's made from just two rays. What will happen if we take the ray pointing up and rotate it like the hand of a clock a little bit to the right, a little bit clockwise? Well, we don't have a right angle anymore because the rays are no longer perpendicular. Instead, we have an angle that's smaller or less than a right angle. Angles that are less than right angles are called acute angles. On the other hand, if we rotated our ray to the left instead of the right, we would get an angle that's bigger or greater than a right angle. Angles that are greater than right angles are called obtuse angles. So there are three main kinds of angles that you need to know about: right angles, acute angles, and obtuse angles. Well, actually, there's one more type of angle that's pretty important, but it's kind of a strange one. It's called a straight angle. A straight angle is just what we get when we rotate our rays so that they point in exactly opposite directions. The result looks just like a straight line, which is why it's called a straight angle. All right then, there's just a few more important geometry terms that we need to learn in this video. Let's look at our simple right angle again that's made from two rays. But this time, let's draw a third ray that cuts that right angle into two smaller parts.
So this is what we're learning right now, okay? So everything else was review, and this is what we're learning right now.
Now, because the angle that we divided up was a right angle, we know that the two smaller angles combine to form a right angle. And in geometry, any two angles that combine to form a right angle are called complementary angles. And we can do the same thing with a straight angle. If we take a straight angle made from two rays and divide it with a third ray, two new smaller angles are formed. And those two angles combine to form a straight angle. We call these angles supplementary angles. So complementary angles combine to form a right angle, and supplementary angles combine to form a straight angle. All right, that's all we're going to learn about angles in this video. And if you're new to geometry, it might seem like a lot. So let's do a quick review of all the new geometry words we've learned. Lines that point in exactly the same direction will never cross and are called parallel lines. When lines do cross, they cross at a point called an intersection. Lines that intersect form angles. You can think of angles as the spaces between the lines. Angles can be named by the points that form them, just like connect the dots. An arc is a part of a circle. Arcs can be used to represent an angle between two intersecting lines. When intersecting lines form all exactly equal angles, the lines are perpendicular. Perpendicular lines form right angles. Right angles are square corners, and we use a special square symbol to show that an angle is a right angle. An angle that's smaller or less than a right angle is called an acute angle. An angle that's bigger or greater than a right angle is called an obtuse angle. A straight angle is formed by two rays pointing in exactly opposite directions. A straight angle is really just a straight line. Two angles that combine to form a right angle are called complementary angles. Two angles that combine to form a straight angle are called supplementary angles. In our next geometry video, we're going to learn more about angles and how to measure them. Thanks for watching Math Antics, and I'll see you next time.
Ooh, awesome. That was a great video we just learned about. Let's go ahead and continue on. So tomorrow we're going to do our mini lesson, okay? And here are your notes for the adjacent angles, okay? Make sure to copy down this in your notebook so that way you have all the notes that you need for tomorrow's lesson and class, okay? I hope to see you next time, and I'll see you tomorrow. Bye.